So now that we've seen the cardiac cycle, when we looked at the cardiac cycle, we looked at like isovolumetric contraction and isovolumetric relaxation, and within those were a certain volume of blood in the ventricles. So we had end diastolic volume, which I just did that wrong, sorry, end diastolic volume, that should be a V, not an S, what I was thinking. So end diastolic volume, that's end diastolic volume. And we have end systolic volume. End So from that, we can actually figure out the volume of blood that was pumped out from each ventricle. So stroke volume is that number. So the total volume of blood pumped out by one ventricle in one heartbeat. So the stroke volume we can figure out from the end diastolic and end systolic volumes. So the end diastolic volume is going to be a big number. The ventricles are relaxed and accumulating blood. So if we take the end diastolic volume and subtract the end systolic volume, we get stroke volume. Because the end systolic volume is going to be whatever's left in there after contraction, after systole. So it's going to be a low number. So that will give you that. So with that, we can figure out cardiac output. So cardiac output is the amount of blood ejected by each ventricle in 1 minute. By each ventricle in 1 minute. So cardiac output is calculated by the stroke volume, which is end diastolic volume minus end systolic volume, times heart rate. All right, so actually in an average human, so if you have cardiac output is stroke volume times heart rate, and the stroke volume is 70 milliliters per beat, and the heart rate is, this is just an average heart rate, beats per minute, then we get 5.250 milliliters per minute. So about 5 milliliters per minute, which is about average. Okay. So what affects, there's two things that kind of affect this number, okay? And one of them is something called preload. So preload is basically the amount of stretch in the ventricles before ejection occurs, before contraction. So the bigger the stretch experienced by the ventricle, the more it's going to push out. Okay, so this is basically the stretch felt on the ventricle walls. Afterload has more to do with resistance. Resistance to blood flow. And resistance to blood flow can have to do with, just the normal resistance is just the resistance of pushing the semilunar valves open. That is a normal resistance. If you have, stenosis in the valve, or something like that, that will increase resistance and make it harder for the ventricles to pump that blood through those valves into those arteries, and it will decrease cardiac output. So increased stretch, increased preload will increase cardiac output, and too much resistance or afterload will decrease it. All right. So I think that's it. And we'll be going on to vessels.